Hello, algebra students. Mr. Lawrence here, and we're going to do two vertical motion problems. I'll give you the equation in both cases. This first one here, I didn't even read it yet, and I saw this feet per second. Since I'm talking about feet per second, my equation is going to be this one. Right? Because I'm in feet per second. If I were in meters per second, the only thing that would be different with this lead coefficient would be a negative 4 9/10. All right, so it says a ball is kicked off the ground with an initial velocity of 80 feet per second. Well, let's write an equation to describe that. H is going to equal negative 16 t squared. The initial velocity is 80. It's positive because the ball's being kicked upward, t, and then it's off the ground, so the starting height is 0. All right, so there's my equation. How high will the ball go? Well, that's a vertex question, right? You know, you should really draw a picture. Okay, here's the ball. The path of the ball is going to do something like this. When I say how high does it go, I'm asking you to find the vertex. So I'm going to do the negative of b over 2a. So a is negative 16, b is 80, and c is 0. So to find the vertex, oops, I guess I should be using t. Okay, I'll have the negative 80 over negative 32. Where'd I get the 32 from? 2a. I expect you to know this by now. All right, I think that's going to come out to be 2.5. I think that's right. Let me just double check that. Yes, 2.5. Does that mean the ball goes 2.5 feet off the ground? No, of course not. What does t stand for? Time. That's the seconds. So right here, it's going to be at 2.5 seconds. I got to figure out how high it is off the ground. How do I figure that out? Well, there's an h in the equation. I do h is equal to negative 16. What's t? Oh, it's 2.5 plus 80 times 2.5. And so I'm going to go negative 16 times 2.5 squared plus 80 times 2.5. And when I do that, I'm going to get 100 feet. So h is going to be 100 feet. So it's going to go 100 feet off the ground. Okay, how long will it take to get there? I know that wasn't asked, but I know the information. 2.5 seconds. Okay, when will it be 20 feet off the ground? Well, I take this original equation here. I plug 20 in for the ending height. And then I get it equal to 0 by subtracting 20 from both sides. And now I'm going to go looking for the zeros. Yeah, the zeros are going to tell me when it's 20 feet off the ground. So A is negative 16, B is 80, C is negative 20. I'll find my discriminant right away. Remember the discriminant is b squared minus 4ac. This should all be old hat. All very simple to you. All right, minus 4 times negative 16 times negative 20. So my discriminant is 5,120. I don't think that's a perfect square. Nope, definitely not. So I'm going to use the quadratic formula. And I'm going to go, t is approximately equal to the negative of b plus or minus the square root of 5,120. And that'll be over negative 32. And now I can go to my calculator. All right, I'm going to go negative 80 plus the square root of 5,120 divided by negative 32. And I get t is approximately 0.26 seconds. Okay, but there's another answer because it's going to hit this height 2 times. It's going to hit it on the way up, and it's going to hit it on the way down again, just like that. So, since I did it on my graphing calculator, I can hit second enter and just change the negative 80 plus the square root to negative 80 minus the square root. And there I get my other time. My other time will be about 4.74 seconds. Okay, there we go. Now I leave you to do the calculations to verify if I'm right. Okay, when will the ball return to the ground? Well, that's an easy one. I take h equal to negative 16t squared plus 80t, but this time h is 0. So I just plug a 0 in. And I use the quadratic formula on this. Now, if you've been paying attention in class and you kind of understand what's going on, you might know an easier way to do this, and that's okay. But if you don't know an easier way, because there always isn't an easier way, use the quadratic formula. So in this case, I've got A, B, C. Easy as negative 16, 80, 0. Okay, my discriminant is going to be a lot prettier. So I'm going to do t is going to be equal to negative 80 plus or minus the square root of 6,400, because the 4ac part will turn to 0, so all I need is 80 squared. And that'll be over negative 32. And so I'm going to get t is equal to negative 80 plus or minus 80 over negative 32. One of these answers is going to be 0, which makes perfect sense because it's on the ground when the time is 0, before you've kicked it. All right, the other time is going to be 5 seconds. And that's the one that is really answering the question because it says when will the ball return to the ground. Okay, so we've got those answers, and this one was 5 seconds. All right, very good. One more problem here. Now, I'm actually going to do all of this. I'm going to have you do it. A stone is dropped off a building that is 100 meters tall. By the way, your equation this time is going to be h equals negative 4 9/10 t squared. It's dropped, so velocity is 0, initial velocity is 0, and starting height is 100. Okay? All right, I want you to pause the video and I want you to answer these 4 questions. Find out when it's 90 meters off the ground, 80 meters off the ground, 70 meters off the ground, and 60 meters off the ground. Okay, and you do that just by plugging in 90 for h, subtracting, and then using the quadratic formula. Then you'll plug 80 in for h, subtract, use the quadratic formula. Go ahead and pause and do that. Okay, if you're still watching at this point, I'm assuming that you've done it for all 4 parts. You don't have to do the 0 meters off the ground yet. But I want you to see that when I do this, I'm going to get approximately that many seconds. And then 80 meters off the ground is going to be about this. And then 70 meters and 85. And what do you notice about the differences in the times? Like the meters are going, it's dropped 10 meters, now it's dropped 20, now it's dropped 30, now it's dropped 40. But do you notice the times here? This is going to be like a 0.5, 714, the difference, right? That's the difference in the times. I just subtracted. And this difference is going to be 45 hundredths. And this difference is only going to be 38, right? Hundredths. Notice how the differences in the time are getting smaller. So in other words, it's traveling 10 meters farther in a shorter amount of time. Just showing you it's not falling at the same exact amount every second. The more it falls, the faster it goes. And that has a limit. It hits that thing called terminal velocity due to air resistance. But we're not going to worry about that in this class. All right, so I just wanted you to see those times there, okay? And then 0 meters off the ground, well, that's easy. We're going to have 0 equals negative 4 9/10 t squared plus 100. And I'm going to go ahead and tell you what the answer is, doing it a different way, but I want you to do it using the quadratic formula. Okay. It looks like I'm going to get about, t should be about 4 5200 seconds. That's how long it should take the stone, was it a stone? Yeah, the stone before it hits the ground. Okay, so about 4.5 seconds. All right, that's your video for today. We've heard of a rumor of a quiz coming up. I would make sure I know how to do all these. Mr. Laurence signing off. Have a good night, everybody.